Good day, everyone. This is my first video on the further mathematics under the curriculum of Cambridge Curriculum, International Baccalaureate or IB, Engineering Mathematics in the Philippines, and for those students who are taking Bachelor of Science in Mathematics. There is always similarity with Advanced Placement of America. Um, the focus for this video is about roots of polynomials, specifically the roots for quadratic equations. I'm expecting that I'll be having two short videos about this topic. If you are just new in quadratic equations, this is not the right um, topic for you. All right, you actually need to go to the basic one. So primarily in this specific video, we might be interested into what is the connection between the sums and the products of the roots and the coefficients in the original equation. So the further mathematics curriculum actually does not focus only into the quadratic equations. Normally in the examinations, they're gonna give you until the fifth power. Okay, polynomials, the power of to the with 5 as the highest power of the coefficient, but they only have the same principle. That is the relationship between the sums and the products of the roots. And so before we proceed to the cubic or to the quartic or to the fifth polynomial, then we actually need to explore first the quadratic equations. So let's try to look at this question so we would be able to, sorry, before I proceed to that one. So let's try to get the relationship for this one first. For us to be able to do that, let's take here a quadratic equation. So let's say that a z squared plus b to the z plus c is equal to 0. Please take note that it's not a typical quadratic equations that you're going to learn in high school, because in high school that's actually x. In this one, I just use z because I want to show that this could actually be other function as well. So, and for us to be able to analyze the sum, take note, okay, we are looking into the relationship between the sum and products, and the equation of the polynomials. That's precisely what are we looking for. The relationship that we are actually looking for. That if you see the question and you know the sum and the products, that then you would be able to give the equation of the polynomial, or the vice versa. That if you know the equation of the polynomial, even if you don't solve for the roots of the quadratic equation, or even if you don't solve for the roots of the polynomial, then you will be able to give the sum and the products of the roots. Okay, so let's say for us to be able to do that, let's say that alpha and beta are the roots of these quadratic equations. And we know that we can actually write this one. We can have a z squared plus bz plus c. We can actually rewrite that one. I think I need to have a wider area of the paper in a factored form, which is a times z. All right, if that is a root, then that's going to be z minus alpha times, if that is also the root, that is z minus the beta. All right, so again, if you got confused with this one, please go back to your basic quadratic equation, because this topic is for grade 11 and grade 12, and for those students in the first year of engineering. Okay, so a to the z squared plus bc plus equals to 0. Then we can write that one into the factored form. Okay, that is actually the factored form. All right, so what we're going to do is let's try to multiply all of this, and we can compare with this one. Okay, please take note. Okay, The one that we're looking for is we want to get the relationship between these two. I just want to make it clear, all right? Because the computation could be like a bit complicated, but that's precisely what are we looking for. The relationship, the sum and the products of the roots and the equation of the polynomials. And what I have said, we are just starting with the quadratic equation. So when you combine this one, so let's copy that. And we can multiply this to z times z is z squared. Z times b is negative beta z, and negative alpha times z is negative alpha z, and then negative z times negative alpha times negative beta is plus alpha beta. All right. So we only just multiply all of this one, and then we can actually factor this one. So let's say a z squared. Let me just try to factor this first. Okay, this one you can factor the negative beta plus alpha, then z plus alpha beta. All right, please take a look. This is negative, so I put it outside, and then this becomes the beta plus alpha. Then you have it plus z, and then now you have it the a z squared plus bz plus c. And now we just need to compare the left-hand side and the right-hand side here. Because these two equations are congruent with each other, they're actually equal with each other. So for whatever value of their z, they will always be equal. So a times beta plus alpha, z plus a times alpha beta. All right. Now, as what we have said a while ago, we are just looking for the sum and the product and the relationship to this equation. Please take a look that in this one, this is actually the sum. That is the sum. Okay. And this one here, that is actually your product. So basically, what are we looking for is what is the equation for the sum and what is the equation for the product. All right. So you have there now a z squared plus bz plus c. So we can actually compare the two. So, but what we want is only this expression. So this expression here is actually equal to this expression there. So let's find that relationship. So bz is actually equal to this component here, which we need to include the minus sign, then a times the beta plus the alpha times the z. And what we want to get is only this one there. As you can see, we can cancel the z, both z there. So we have there now the b is equal to negative a times, I just want to make it alpha plus beta, so it looks better, right? And what are we looking for is the alpha plus the beta. So therefore, we can say that both divided by negative a, both divided by negative a, then we have the negative b over a is actually equal now to your alpha plus beta. Okay, and please take note of this, because this equation is not only true for quadratic equation, that's also true for other polynomials, right? But I will not discuss that one in this video because this is only an introductory video. And then now we're going to do the same thing for the alpha beta here. This alpha beta, this is actually the constant, and the constant part of the left hand side. Please take a look. The constant part of the left hand side and the constant part of the right hand side, we are going to make them equal with each other. Okay, so the constant part on the left hand side is c, and the constant part here is actually equal to a alpha beta. But again, what are we looking for is only this component. So therefore, how shall we do that one? We need to divide both of these by a, so we will be able to cancel that. All right. So therefore, c over a is actually now equal to alpha beta. Now, what is the relationship? What is the implication of that one? So I will just give you a very simple example that, let's say I have 2x squared plus 3x minus 4 is equal to 0. All right. So by just looking into this, what is the sum of the roots? What is the sum of the roots and what is the product of the roots? This one will actually give us the answer. It says it is actually negative b over a. But please take note that in this one, a equals 2, b equals 3, and c is equal to negative 4. All right. So what is now the sum? The sum is just negative b over a. So the negative of b, which is 3, over a, which is 2. So therefore, the sum of the roots of this, if we will find it, is equal to this. Even if we don't find it, this is actually the sum. All right. And then now we're going to have the product. So the product here, it says c over a. So your c is negative 4, and then your a is 2. So that's equal to negative 2. All right. So again, that is the relationship between the sum and the products of the roots and the equation. All right. But again, this too is very important. So I will just, let me just take some paper. Okay. Actually, you only need to memorize this two, and the alpha plus beta is equal to c over a. And take note, every time you see this one, it means the sum and the product. So let's try to look at the first example in our slides. Let me just check the time because I don't like this video to be that long. Find the quadratic equation with the roots of 5 and negative 3. All right. Oh, by the way, let me just write that a z squared plus b z plus c is equal to 0. And if we all divide this by a, we're gonna end up with z squared plus b over a z plus c over a equals 0. What is the relevance of this is that the sum is actually similar to this, in negative b over a. So therefore, you can actually rewrite this one as z is equal to negative b over a, z plus, that is now c over a equals 0. Okay, now let's try to write this one in words so it's gonna be make sense for us. That's actually z squared minus the sum of the roots, z plus that's actually the product. I'm pretty quite sure that when you were in year 8, you have learned this one. Okay, but again, this is not the focus in further maths. So I just want to show you that you can actually interchange that symbol, that symbol. That's the most important there, because as you study for the cubic, for the quartic, then you're going to encounter the same thing and it doesn't change at all. So that is now the relationship. Please try to look at this, try to look at this one here, and let's try now to answer the question. Find the quadratic equation with the roots 5 and negative 3. In this one, the alpha is equal to 5 and the beta is equal to negative 3. You can have it either of the two, it doesn't matter. But what we're looking for is actually the quadratic equation. So therefore, that's actually x squared minus, it says the sum times the z. 5 plus negative 3 is berapa? 2. So you have there 2, all right? 2, 2x plus the product is 5 times negative 3. Okay, that's negative 15. So I shouldn't put this one here there. So this is now equal to 0. Please take a look because that's the format. X squared, okay, minus 2 times x. Where did I get that minus 2? Because it's just minus the sum. And the sum is 5 plus negative 3. Then you have there the product. 5 times negative 3 is negative 15. So that is now the final answer for the first one. All right. Uh, this topic is actually very exciting. So if you love math, then you will be able to appreciate this one. Find the roots of the equation if you have the 2z squared plus 3z plus 5 is equal to 0, or the roots are alpha and beta. Find the values of alpha and beta. Um, and then you have what? Find the quadratic equation with the roots 2 alpha and 2 beta. Let's see. So in this one again, please don't panic. It looks difficult, but actually it's just easy, right? Again, in the question, it says the alpha and the beta are actually the roots. So how you're gonna do that is, let's try to rewrite this one into this form. Okay, so you have there z squared plus 3 over 2z plus 5 over 2 equals 0. I only, all right, I only divide the each term by 2. Okay, but again, the sum is this equation is minus the sum. So let's just try to write z squared minus the negative of 3 over 2 z plus 5 over 2 equals to 0. What does it mean is that the alpha plus the beta is equal to negative 3 over 2, and the alpha times the beta is equal to 5 over 2, like that. Okay, and that is actually the answer in the first question. Question number 2. The question number 2 is that find the quadratic equation with the roots of 2 alpha and 2 beta. Please take note how powerful is this one, because now 2 alpha and 2 beta, meaning to say the two equations are connected with each other. Without basically solving for the roots, we would be able to get the relationship between the equations. And that is the purpose of this one. As a further math students, you will be able to see the relationship between, you will be able to deduce the two functions or two quadratic equations which are related with each other. I think I'm talking too much. But anyway, let's see. What we're gonna do is just simply solve these two and solve for alpha and the beta. I think that's the easiest way to do this one. So we can have their alpha. The alpha is equal to 5 over 2 beta. Okay, and then what we're gonna do is simply substitute this one here. Okay, so you have their let's plug it in here. Let's plug it in there. So it's so difficult if you are doing see, because I have no answer beside me right now, so I'm just doing everything on this spot. So you have there now, we're trying to solve this one now. So you have what to do here. We multiply by 2 beta, so we remove this one. So that is now 5 plus, we multiply by 2 beta, all of this one. So that's going to be 2 beta, 2 beta squared is equal to negative 3 over 2 beta. See, now we have a quadratic equations for beta, and now we can solve this quadratic equation. So we can just rearrange 2 beta squared plus 3 over 2 beta plus 5 is equal to 0. All we just need to do is just simply take a calculator and solve this equation. All right. Let's see. Now it's getting complicated. This is actually the problem because I don't have the mark scheme beside me right now. Oh, hold on. I found a new way. Wait. All right. Let me just, again, without finding the roots. I don't like to find the roots. Okay. Let's go back to the principle. What we have said is the principle is that the z squared minus the sum, okay, The c squared minus the sum z plus the product. Okay? I think what we can just take is the new sum and the new product. So because these are the roots, so 2 alpha plus 2 beta are the new sum. These are the new sum, or this is the new sum, I mean, which is equal to 2 alpha plus beta. And fortunately, the alpha plus beta is given there. So that is now 2 times negative 3 out of 2. You cancel the 2, that's actually negative 3. Oh, it's not visible. All right, now let's try to look for the product. So it says 2 alpha, 2 beta. So the product now is the product, okay, is 2 alpha times 2 beta, which is 4 alpha beta. And that is 4 times our alpha beta based from our first answer. Okay, our alpha beta is 5 out of 2. All right, 5 out of 2. Now, this is now 4 divided by 2 is 2 times 5 is 10. So therefore now, the equation, okay, the new equation is equal now to um, um, x squared minus the sum. And what's the sum? Minus 3. Minus 3x plus the product, which is 10, equals to 0. Then we can just simply simplify this one, and it will give us x squared plus 3x plus 10 equals 0. But you know what? I think because this one is in terms of z, and as what I have said, they are connected with each other. So I will just use the same variable. Okay? I will just use the same variable. Because again, as what I have said, the two are connected with each other. It means if the first equation is in terms of z, then the connected equation must also be in terms of z. All right, so that's the answer to this question. All right, the next question is the roots of these equations are alpha and beta. Find the equation with the roots of alpha plus 1 and beta plus 1. Um, I don't know if I still have time, but anyway, let's just continue with this. So it says 3z squared minus 4z minus 1 equals 0. You divide this one by 3, divide it by 3, divide it by 3. So you have z squared is equal, z squared minus 4 out of 3z minus 1 out of 3 equals 0. What does it mean is that the product, the alpha plus beta, I mean the sum, the alpha plus beta is equal to 4 out of 3. And then the alpha beta is equal to negative 1 out of 3. All right. And the question is that what is the equation with the roots alpha plus 1 and beta plus 1? Again, all we just need to do is simply take the new roots or the new sum, which is alpha plus 1 plus beta plus 1. So it's alpha plus beta plus 2. But now we know the alpha plus beta is 4 out of 3 plus 2. That one will give us 6. 6 plus 4 is 10 over 3. All right? And then now that is now the answer for the sum. That is now for the sum. And then now we take the product. So you just need simply take alpha plus 1, beta plus 1. So that's going to be alpha, beta plus beta plus beta plus 1. However, we know the product already. The product alpha beta is actually equal to negative 1 out of 3 plus alpha plus beta is equal to 4 out of 3 plus 1 equals, yeah, that's it. That's what we're looking for. So negative 1 out of 3 plus 4 out of 3 is 3 out of 3 plus 1. That's actually equal to 1. So therefore, that is now equal to 2. Therefore, the new equation with the roots alpha plus 1 and beta plus 1 will give you z squared minus the new sum, and the new sum is 10 out of 3. 10 out of 3 z plus 2 is equal to 0. All right. Hopefully, I did not extend to 15 minutes on this video, but anyway, how I wish that I would be able to upload this one in YouTube. All right, that's all from now. Thank you very much.